So welcome to the 13th webinar organized by AIGS. I'm Michelle. It's so delighted to be here again. So I'm thinking you are all having the weekend, so I hope you have a nice weekend. So today we invited a well-known expert in color stone. He's Mr. Chris Smith. I know a lot of people know him very well. So I will just do a little bit background introduction. So Mr. Smith, he is the CEO and owner of American Gemological Laboratory. He was previously the director of the Googling Gem Lab and the past director of identification service for the GIA laboratory. He has been working in these gems and the jewelry industry for 35 years already. So he has a very distinguished international career. And he has specialized research in color stone, diamonds, treatments, and region analysis. So his research has won him numerous awards. He also has visited a number of the most important gem mining areas. So today, Mr. Smith is going to give a talk on the color referencing system, ColorCodex. So I think many of you have been heard about ColorCodex already. And for us in AIGS, when we are grading color stones, either in the laboratory or in the school, ColorCodex has been one of the most useful tools for us. So I hope you will enjoy the presentation and learn something about color from Mr. Smith. So now I will give the floor to Mr. Smith. I think you can't wait for that already. So hello, Mr. Smith. I will try to invite you first so we can hear you. I think you are here already, right? So I'm trying to invite you to talk to everyone and say hello to everyone. Okay. So
hello?
Here you are.
Can you hear me?
Hello, Mr. Smith. Yes, we can hear you. How are you?
I'm very good, thank you. It's early Saturday morning, but I'm happy to be with you.
Okay. So today you will give the talk, very interesting talk about ColorCodex. So now I will give you the floor so you can try to share your screen.
Okay, so let me, just for everyone, I'm not so familiar with doing webinars, so please stick with me. I'm going to share the screen here and see how, just a moment. Share.
So everyone can hear me or hear Mr. Smith, right? So I just want to check because I saw Crouch in the chat say you can't hear us, right? I hope, okay, so you can hear me, right? You can hear Mr. Smith. Okay, great.
So you can hear me? Everyone can hear me?
Yes, so everyone can hear us. Yeah.
Okay. So first I wanted to say again,
so now
hello to everyone. I wanted to thank Michelle and the AIGS for inviting me to speak to you today. So good morning for those over here in the US, good afternoon for Europe, good evening for those of you in Asia. When Michelle asked me to speak to you today, I kind of decided to speak to you about the ColorCodex system. And that's because this is a tool which I had developed for the industry to help the industry with several areas of its business. And, you know, we're all kind of, the world is going through quite unprecedented times now. And as we start to come out of this and we start to get back to work, we may find that certain things in our industry are changing or need to change, especially relating to things like social distancing. We don't know how long that may be in place. And so things even like trade shows may be impacted for the short to midterm. And so people need to, my thinking was that the industry may need to look at different ways of communicating with potential suppliers, potential clients about stones that they have. And so the ColorCodex system, this is one of the tools that I had developed to try and help people with that. So I'm just going to kind of jump in and I'm going to introduce the system and some applications for everyone. So I always start these talks with this kind of description of gemologists lost in color space, because I think this is kind of an accurate description of things, because when I've spoken to people, whether they're in the trade, traders, consumers, I think most people see color in a more linear fashion, like what you see presented here. So it goes colors that are extending from paler shades to richer or more vividly colored shades. And so they see it in a very linear kind of fashion. But in reality, color is more of a three-dimensional model, as you see represented here. And so there are three essential components. Using this model, you can see, so around the perimeter, I'm going to try and use my camera to show. So around the circle perimeter, these are the different colors that you're going to see represented. The center point in the middle, which is white, so extending out from here, this is saturation or intensity of color. And along the vertical axis, this is where you have lightness, the scale of lightness to darkness, or the influence of tone. And it's actually the combination of these three elements which merge or blend to give you the overall color appearance which you may see. And you can see it quite well represented with the little squares in this diagram. But this is a much more kind of complicated model for how to understand really what's happening with color. There's a whole science that's devoted to color, and so it is quite an in-depth and detailed area or field. And most people in the trade, as well as consumers, they really don't have the interest, by and large, from my experience, to kind of go into this. And so in the industry, what we've tried to do is we've seen the integration or the use of different systems to try and help communicate color. So some of the systems that have been used in the past have been borrowed from other industries. You have the Munsell color book, you have the Pantone color book. These are developed for the paint industry, the print industry, the textile industry. We also have some products like the Gem Dialogue or World of Color, which were developed specifically for the use of stones. But all of these tend to be on a paint or a print type of format. And so there are certain limitations which I'm going to talk about. We also have some computer-based or internet-based systems. Jimmy Wizard, I think, is the one that's most well-known. I think you had a webinar about this a little while ago. Omar from the ICA lab also kind of mentioned at the Congress last October that the ICA was going to look into developing something like this. But all of these systems, they have a certain kind of fundamental limitations. And the biggest part of that limitation relates to the gamut of color which is achieved through these various methods. And so this diagram that you see here, this kind of illustrates in that central region the extent of color that can be reproduced either through print or through the various techniques that we're talking about. The outer web or mesh of color that you see is actually what we can perceive. So you see the eye and what nature can produce, actually. So the eye and what nature can produce actually extends outside of that. And so I want to show you what this means kind of in real terms. I'm using pages from the Munsell book because Munsell, outside of the gemstone industry, Munsell book is one of the standards for colors, standardization. And that's why, obviously, it's been adapted for our gemstone industry. But here you see a ring, which was submitted to the laboratory some time ago. And I put it on the kind of appropriate page of the Munsell color book so that you can kind of see. The first thing that kind of strikes you is this is a transparent faceted gem. And so the appearance of a transparent faceted gem is kind of hard to translate against an opaque flat paint chip. At the same time, the nuance of the hue of the color is kind of not well represented on this page of the Munsell color book, but this was the best match we had. And there's an intensity or a vividness to the color, which also you don't see represented on this page. And this is in the yellow region of color. When you go to the red region of color, you really see where the limitations come into place. Because this here, the stone that you see in the lower right, this was a very, very nice ruby that came into the laboratory. It had really a beautiful, remarkable color. And this is it's sitting on the Munsell color book, the page of the Munsell color book, which came as close as the system has to this particular ruby. And you can see the nuance of the color, the shade of the color of red that we're dealing with, as well as the vibrancy and the gamut of color just isn't able to properly or adequately represent such stones. And so these are the fundamental kind of limitations which we're encountering with the systems that have been available up until now. And so just as a kind of summary, where this has led to is that we've had over the years several products that have been available to the industry, but none have been kind of broadly accepted or broadly adopted throughout the industry. And this is because they all kind of fail to present or represent color as we see them in transparent faceted gemstones. You know, transparent faceted gemstones, these are a three-dimensional body, right? And this is interacting with light as it's passing through it. You're creating brilliancy, internal color reflections, as well as blackened areas of extinction. And as you kind of tip the stone and look at the stone, you're going to also see that this mosaic of colors and characteristics that you see is also going to move. It's alive, so to speak, when it comes to looking at these. And so it's very difficult to compare to opaque, flat color comparison sets. And so I lead to this because I think this discussion of trade terms, it's obviously a much bigger discussion, but I think we find ourselves in the situation of trade terms because of the fact that we haven't had really a good or adequate system for presenting or representing color in gemstones. But the question is, does this actually accomplish, are these trade terms actually accomplishing in the practical sense what the industry was looking for? Because obviously the industry, the reason they went to these trade terms was because they were trying to find a way to help describe color or communicate color or qualities of color to the industry or to clients. But this is something which, I always use this reference, diamonds, decades ago, you had things like Wesselton, top Wesselton, river. These were terms, kind of broadly generalized terms to communicate color. And the diamond industry recognized already decades ago that if it wanted to move forward in a good and a healthy way, they needed to get away from these kinds of terms. And I just find it a little bit ironic that the colored stone industry is actually going back to things such as this. But this is because we haven't had an adequate system to help with the topic of color. And so this has led to what I described as this color conundrum. Because the ironic thing for me is that once you take white diamonds out of the picture, our industry is all about color. It's an industry that's centuries old and it's all about color. Yet we don't have a good system. We haven't been able to develop a good system for really representing color or referencing color for the industry. And so this is what led me about 3 years ago to start looking into this topic from a different approach. And I tried to kind of overcome these challenges that the other systems have had. And this past year in Tucson, in February, we officially launched the ColorCodex system. Now, I also want to give credit to the predecessor of this. What inspired me to do this was a system known as the ColorScan, which was developed by AGL and another gemologist, Cap Beasley, back in the 70s. But this was produced at the time only by on a small number, and it's not commercially available today. But it was the inspiration for what we have and what we find with the ColorCodex system today. So what I want to first kind of explain a little bit the challenges that you have with faceted stones. And that's because the faceted stones, the appearance, the overall appearance of a faceted gemstone, this is really a mosaic of features. You have brilliancy, you have internal color reflections, and you have blackened areas of extinction, as I had described before, and you see them represented in these images. And so this is why, or one of the main reasons why the other systems don't properly present or represent color as we see it in a colored stone. So this was one of the things that I looked at with this ColorCodex system. And so one of the innovations that came out of this system is we have patterned color windows which create the impression of brilliancy as well as blackened areas of extinction. And as a result, it kind of best mimics the way we see color in transparent faceted gemstones. Another advantage of the system is we have significantly expanded the gamut of color, dramatically expanded the gamut of color, which we were able to achieve. And it's an observer-based system, so it's easy to use. It's actually quite intuitive once you start working with it. But most importantly, it allows for consistent and repeatable results. It also works equally as well for loose or for mounted items, so it has the versatility of this as well. So one of the things I also want to describe is that when I was developing this system, I wanted to kind of avoid potential pitfalls of a system. And so I purposefully want people to understand that the system is not designed, and nor was it intended, to try and dictate how colors must be defined or how colors must be described. Rather, I chose a numeric convention for these sheets. And this was chosen purposefully so that we don't distract from the intention of this system. This is a color referencing system. And this way, users still have the freedom to describe colors however they like, using the subjective verbal terms. You know, depending on one's familiarity with color science, one's education with color, you can even have cultural differences, regional differences. People are going to describe color, or the way they're going to communicate the impression of color that they're seeing is going to differ. And so I didn't want to get caught up in those kind of descriptions. But what is important is that anyone using, regardless of what your background may be or where you may be located, everyone is going to come to the same color reference or numeric reference for a given stone. That's the important aspect of the system. And so if I describe a little bit more about the system, it actually comprises 13 pages. You see they were kind of color tabs for convenience to see. And each page actually has, let me see, I think here. So we have 5 columns on each page, which means these are one particular hue. That is, you'll see. And then we also have 8 rows. And these 8 rows are representing the progression of color intensity from paler or lighter shades at the top to richer and more saturated, more vividly saturated colors towards the bottom of the page. And now at each color window, what you're going to see is you're going to see 2 numbers, and this represents the hue and intensity. The first number, which I've highlighted here, you see it's 30, 32, 34, 36, 38. This is why that page is represented as series numbers 30 to 38. And these are evenly numbered, and these are representing, as I mentioned, the hue. So you see the progression of hue on this with each page. Secondly, the second number, what this represents is the intensity of the color. And these are numbers going from 0, 3 to 17, and these are oddly numbered. And when you combine these 2 numbers, for example, we have a 3005 highlighted here. If you have a stone and it's matching that particular color window, the colors are matching, this is the ColorCodex reference. So it's a very simple, very easy to understand. First number is the hue or the color column, and the second number is the intensity level. So what you want to do, as I mentioned, this is observer-based. So you're going to want to just compare the stone directly to the sheets and choose the window that best represents the color. So I pulled out a sheet. I even have a stone here that I wanted to kind of show how, whenever I'm teaching people how to use this. So this is the size of the sheet. See how you can see it. And when you have a stone that you're going to be looking, what I always describe to people, the first thing to do is kind of go from left to right to settle on which column of color most closely represents the stone that you're looking at. And then once you've settled on a particular column, then you look on the vertical to see what's the relative intensity of this color. And this is just from a practical application, it's kind of the best way we found the best way to do it. To come back to the numbering of this, I purposefully chose the numbering that we did using even and odd numbers for these 2 for the color windows, because I also wanted to build into the system the recognition that you're going to have stones that fall in between 2 color windows. And so as an example, you see here a yellow sapphire, and it's positioned here because the color is falling between 2 of the colors. On the left, you have 50. On the right, you have 52. And it's in between these. It's at about the 0.9 color intensity level. And so here, the system has already anticipated such stones. And so the ColorCodex reference for this item would be a 51-09. So you have this in place, the same for the color intensity. For example, if you have a stone that is falling, the intensity of the color is falling between 5007 and 5009, then again, system already has anticipated this. You have a color reference of 50-08 for a ColorCodex reference. So as a result, it's quite flexible and it's a quite robust tool. Now, the third element of color, which we haven't talked about yet, is tone, or the lightness to darkness. And so in nature, we find that virtually every type of gem may be modified by nuances of gray or brown. And this is the influence of tone, or a tonal value. And so the ColorCodex system specifically was designed to handle these with the use of overlays. So let me kind of show you what an overlay. It's got two windows, again, because it's a color comparative system. And so what you do is simply, as you're looking at the stone and you're trying to compare, you simply overlay the tonal chart, and you can see how the tone is going to be influencing the color. And you do this to try and find a better match for stones. There are 5 levels of tone which are represented in this system. So you have 5 different overlays. And here I want to use an example to kind of show you. This is a garnet from the AGL reference collection. And so we're on the sheet, the ColorCodex sheet, where the color is the closest. And so you see it falling here. It's similar to like the 10-07 color window, but if your screen is representing or showing the stone the way that I see it on my screen, you're going to see there's an element of tone here, which is the color is slightly different. And so with the use of a G1 overlay, you see you actually get a much better match for this color. And so now the ColorCodex reference for such a stone would be 12-07 plus G1. So this is how we use the overlays to bring in that third dimension of color. Now, I'm not going to spend a lot of time talking about technical data. This is something my colleague Riyadh and I have been working on. We've been collecting a lot of data on all of these color windows. This is for another type of presentation or publication when we get to the point of it. But there's a lot of things that have to be considered in order to collect really good, robust color data. And so this is not as simple as one might think. This is an example of what we're looking at, but you have issues that you need to consider. Things like your standards for the color. You have to decide, there are many types of color space. You have to decide which area of color space you're going to choose. And you have also your measuring conditions. And so you have to refine and optimize your measuring conditions. As I said, this is a much more complicated topic than most people realize. It took us quite a while to really optimize everything in this regard. So here's an example of some data that we're collecting on just one color window. Now we decided on the right, you'll see here the CIE color chart. And we decided on the CIE color chart because one of the real innovations of the CIE color chart originally in 1931 was they represented color in terms of dominant wavelength. And so this is something which, besides having, or in contrast to having XYZ coordinates for the 3-dimensional color space, they're using dominant wavelength to position the hue. And this is something which I feel speaks much more directly to gemologists or people in the industry. Most people realize, 400 nanometers is down over towards the blue to violet range, 700 nanometers is over towards the red range. And as each of the nanometer readings that you're going to see, this represents a position in the visible spectrum. And so this is something that most people have a base or fundamental understanding of. And so I thought choosing dominant wavelength to represent the colors in the ColorCodex system from an analytical side made more sense. And so here you see the sheets, the 13 sheets of the ColorCodex system, and how they kind of pan out in the CIE color space. So you see a very nice progression of this color across the color chart. In 1931, however, I want to draw your attention to this quadrant in the lower left. You see it's a lot of congestion here. And so even science is evolving. And so as the decades kind of went on with the CIE system, people recognized this as a limitation. And so in 1976, they redrafted the CIE color chart. And so you see that same region now has been significantly expanded to help bring clarity or better understanding of the colors in this space. And so we're actually, when we're plotting them, we use both charts. We find them both very good and very adequate. And again, you see a very nice kind of progression of the sheets across the color system. So that's just a quick kind of discussion of the technical side. Now I'm going to talk about trade applications. Now, trade applications are not my strong point. I'm an analytical guy, but I'm going to try and give you some examples here, because this is really a tool for the entire industry. And so these are some obvious kind of applications that I felt. You have for gem dealers and suppliers, this can help them better match stones and fulfill inquiries. Again, thinking kind of going forward, people are going to need to be communicating a little bit differently perhaps, and so there may not be as much one-to-one kind of contact. You may have to vicariously try to fulfill orders. For jewelers, you can better communicate their needs. For appraisers or valuers, you can reference color for insurance value or replacement value, and in case something gets lost or stolen, you can actually replace like with like because you have a exact color reference. For trade organizations, I see a great benefit to trade organizations because here, using such a tool, you can provide a better understanding of gem varieties and also trade terms for not just the industry, but also for consumers. So as you're communicating at large, a lot of people look to the trade organizations for clarity. And so a tool such as this can really help clarify what are the boundaries and what are the different aspects that you may find in color related to different varieties. For young gemologists or those entering the trade, this really helps you to ramp up and learn about color and gems more quickly. As Michelle was indicating, the AIGS is incorporating the ColorCodex system in their education. The GEMA is also including it in their education, and that's because this is helping shorten the education process. Most of us had to learn through attrition, so it took time to really have an understanding of color, how the color of a savorite is different from the color of an emerald, or what happens when you start to add the influence of tone and so on and so forth into these. This is a tool which allows you to kind of demonstrate that, explain that, and utilize it much, much quicker. For laboratories, this is where I'm most familiar. We can use this system to establish better criterion and consistency for color descriptions that we want to use, but also for varietal calls, and for those labs that are using trade terms on the reports, also allows them to refine a structure for this as well. So I'm going to give you an example of what I'm kind of thinking here. And this is a stone also from the AGL reference collection. It's a chrome tourmaline. And so I'm going to pretend I'm a jeweler, and I would say I have this chrome tourmaline, but I want to find a match for it. I want to find a pair. So I'm going to call up a supplier, one supplier or two suppliers, so forth. And I'm going to explain to them, this got a very nice color. You know, it's oval, it's this weight, it's got these kind of dimensions, but how to try and describe the color in a way that the person I'm speaking to over the phone understands is challenging. So a supplier may have a stone such as this, and it's also got a very nice color. It's the right shape, it's the right size. So this can look like an adequate pair for the stone or match to the stone. So normally what would happen is you would send these stones to your client for approval. But let's look at it in terms of using the ColorCodex system. So the first stone that I showed you had a ColorCodex reference of 68-10. The second stone that I showed you had a color reference of 70-10. So the intensity level is the same as far as that. The hue is a little bit different, not a lot, but a little bit different, but there's also a tonal aspect to this stone because it required the overlay. So it's still close, but because you have the ColorCodex system, you're able to fundamentally look at the things side by side. And so you can decide for yourself. Certain people may think this is a good enough match for them. They would go ahead and say, yes, this works for my needs, and please send it to me, and you can finish the business. Others may be a little bit more strict. They may say, no, I want something that matches better. And so this would then save everyone the time and the cost of sending a stone out and having to send it back because it didn't quite adequately match the stone. And obviously everyone is using pictures today, but pictures, depending on the computer screen or phone screen that you're using, depending on the lighting that was used, depending on what kind of color manipulation had been done to it, you can't always rely on this. This is a tool where when you have it, the color consistency is very, very good. And so the next one I'm going to use is actually tourmaline, because this is a more challenging one. Tourmaline colors are often very, very difficult to try and describe. There are several times that we get tourmalines in the laboratory where I'm kind of scratching my head and I talk with the other gemologists in the lab and say, okay, how do we see this color? How do we want to describe this color? And so here's one. It's got some pink, it's got some orange, and you want, again, there's going to be a client. This time I'm going to make all of you the jeweler, and you're going to be looking for a stone to match this piece. And so you contact your suppliers. So one supplier, they've got a stone like this. It's a pink, it's got a little bit of orange in it, so they think it might be a good match. Another one has a stone like this. Also, it's got some pink, some orange. Now here you see there's an influence of tone. There's a little bit of brownish in the color. It wasn't described perhaps when they were talking to the client, but again, when the two people were speaking, but again, you don't know how everyone is communicating the color that they're looking at. And then you have a third stone. And so let's go with the instance of, again, all of you are the jeweler who's looking to match the stone. You make a ColorCodex reference and you come up with 30-06. And from these different suppliers, you get back these color references. So you don't have the stones that you can look at, but by looking at these color references, you should pretty quickly be able to see which stones have a good potential or the best potential to be a match. And so when we look at them, I'm going to move on to showing them side by side. You'll see, for example, the first stone, the stone that you're looking for, you're in the color column of 30. The stone that's on the right is in the color column of 24. So this is quite far apart. You see the stone when they're next to each other. Obviously, it's got too much pink to be a good match. Beautiful stone, but it's not a good match for the stone. The next one that we see, okay, the color column is now 27, so it's closer to 30. The intensity level is the same, but here again, which I described, you have a tonal value, which is also present in this stone, so it required the G2 overlay. And then the third stone, which is the 3005, here you're in the exact same column of color. The only difference you have is a slight difference in the intensity of color between an 05 and an 06. And so when you know, even without seeing the stones, you're going to have a very good match. And this is, for most people, should be an adequate match. So it helps you to define. So I'm just trying to demonstrate applications. Here I'm going to move where I'm more comfortable. This is the laboratory applications. And so here, even when we started with this, we didn't see the potential for all applications. One that I like to describe is with unstable colors, sapphires with unstable colors. I'm sure most of you are familiar with this issue that's kind of entered the industry in the last few years or a couple of years. And so these are stones that have a trapped hole center. And sometimes these trapped hole centers are stable, and sometimes these trapped hole centers are unstable. And when they're unstable, they can be inactive or they can be active. And sometimes this can lead to sometimes quite dramatic color differences. And so we've found from a practical side in the laboratory, the ColorCodex system is very, very helpful to kind of establish the color in the active state and establish the color in the inactive state. So that in the future, if anyone has a question, they can come back. We've got these color references, but it also helps us to set the boundary or criterion for when we decide to disclose as an unstable color. Because you have this whole progression of just very subtle shifts in color to much more distinct or dramatic shifts in color. And at a certain point, it becomes to the extent where you feel, okay, this needs to be described or disclosed as an unstable color center. And the ColorCodex system helps us to be consistent in that, to set these boundaries and to be consistent. But where I really see the benefit for the industry, for labs, is in variety designation. So here are just some obvious examples using corundum, topaz, tourmaline, garnets, and spinel. And so here I'm going to talk a little bit more about this. So this is actually a slide that I borrowed from Michael at the SSEF. He gave a presentation on this topic at the Swiss Gemological Conference last year. And so here he's explaining, you can see on the top in the upper right, you have two different ways that we're looking at trying to set, as laboratories, what we're trying to do is set boundaries for color varieties. So one is based on color only. So this is just the visual appearance of the stone. But also what we try to do in the laboratory that you can see on the right is wherever possible, we want to try and create objective criterion as well. This is using spectroscopy or chemical composition. And how labs have looked at trying to set these boundaries in the past, you can see two options. Most of us, we've looked at creating master stone sets or reference stones. And for any of you who have actually gone through the process of trying to create a master set, this is an arduous task. You have to look at a lot of stones before you're really able to select the ones that represent the colors that you're trying to represent. And that's just for one set. Now imagine you're an organization which has 2 locations, or maybe you have 3 locations, or 5 locations, or 10 locations. You have to now replicate that set. And so you need to find the exact same color of stones in order so that all of your branches can have and the same type of master set. And then imagine it's not just one organization, but you're trying to get consistency across the industry. So you're involving many different organizations. Now you're trying to, again, exponentially expand the number of master sets which you need to create. And this is why you start to see where harmonization and standardization has been so difficult. One, finding the stones. 2, the budgets necessary to acquire these stones. Different organizations have different budgets. And this is where you see the development of color charts. Michael uses the Munsell and the ColorCodex charts. And this is where these are coming in, because these are more broadly available to everyone. Michael's showing here a sapphire, which he uses the ColorCodex to kind of show the range of color for his royal blue. But here I want to break these down a little bit, and I want to show the applications with the ColorCodex system. So the first is just based on color appearance alone. And so here, corundum is a perfect species of mineral to use this because you have many gem varieties which are based strictly on the color. But the one I want to focus on is really this ruby pink sapphire border, or what I more appropriately describe as a ruby non-ruby border. And so on the right, you see a progression of stones from a lighter shade of pink to a more intensely saturated red. And at some point in time along this, you're going to see that the stones transition to what the industry may call a pink sapphire and what the industry may call a ruby. But is it really just an indication or a factor of color intensity? What if the color of these stones, you start to increase the amount of purple? At what point is the stone no longer classified because it's too purple? On the opposite side, as you increase the presence of orange, at what point does the stone would no longer be classified as a ruby? So you not only have the hue, so it's going to range from all the way from a purple red through a pure red to an orange red, through the color intensity. And then you also have the third element, which is the tonal value, which is going to be on the lightness to darkness. And so no system up until now has been really able to represent that well. And this is why you don't have a good standard in place for the industry yet. That is up until now. The ColorCodex system is actually very well suited to helping the industry address issues like this. And so for the first time, we can get a lot of organizations together, we can get a lot of laboratories together, and we can start to discuss things like this and really have a material impact on improving the understanding of what makes a stone a ruby. In the ColorCodex system, this is the first sheet of the ColorCodex system, just to kind of show you how we've kind of mapped this out a little bit in the AGL lab. We used actual stones here. So the first thing that should kind of strike you is the fact that actually the the designation of a pink sapphire is much broader than most people probably realize. Excuse me. As you progress to the left, you're going to see increasingly more purple coming into play. But as you increase the saturation, there's a point where you're no longer being classified as a pink sapphire, but you're not a ruby either. You're more in a fancy sapphire range. Where you first start to see the ruby designation is in the lower right-hand corner. And so this is the first time where you start to see the progression of what we would classify, what we've classified as a ruby. As you look at the next page, the 20 series, here you really see where the boundaries for ruby are most encountered. And here you see on the left and in the center, you see the progression, the kind of classical progression of the intensity of color being the boundary between ruby and pink sapphire. But what's also very useful with this system, if you look, for example, on the far left, you have the distinction, you have a color window of 2011, and you have a window of 2011 and 2013. And so when you have a stone which falls in between this at the position of a 2012, this is really a borderline stone. Same with the column next to it. You have 2209 and 2211. So if you have a stone that falls at the designation of a 2210, again, here you're looking at a situation where these are the real borderline stones. What you also find on this page is the first border for the distinction and the transition from a pink sapphire to a podparacha. So from an orangey pink sapphire to just what would be classified as a pink sapphire. As you continue on to the next page, you see the ruby topic is now gone. We're no longer talking about these, the stones are too orange, but you have the remainder of the podparacha discussion. And here you even see, are there other elements to the podparacha discussion besides just the hue? Is there also a color intensity? So I've left two color windows with a question mark to say, is there a point where the intensity of the color also would place it outside of a podparacha call? And here you also find between the columns of 34 and 36, so the column of 30, the position of 35, this is the boundary of where you're going to have a pinkish orange sapphire and what would be classified as an orange sapphire. And so again, you're able to very well kind of map out all of these boundaries. And by doing this, you're able to then it's much easier to communicate it. It's much easier to demonstrate it, whether as a trade organization to members of the trade or even with consumers. They have a reference that everyone can look at. So the next approach that we want to look at is when, again, as a laboratory, we try to complement or wherever possible, create objective criterion to complement the subjective criterion. And so here we use spectroscopic or chemical data. So I'm going to use a couple of examples here. One that I did recently and which was published in Color magazine, it talks about the precious topaz and imperial topaz. So these are two terms which have a long traditional use in our industry. However, if you look in publications and if you look on the internet, you see that these two terms are really in many, many areas, they're virtually interchangeable. There's so much overlap. In general, I think there was an understanding that precious topaz was a little bit more on the orange side or the yellow side, whereas the imperial topaz was more on the kind of reddish orange or pinkish orange to pink color side. But when you're looking for references, written references in publications or on the internet, you see these are overlapping a lot. However, we looked at this from the laboratory side to see if we couldn't then kind of respect these old terms, but create more objective kind of criterion. And we did that through spectroscopy in the presence of chromium. So you can see here the two spectra for what we classify as imperial topaz. Here you see the clear absorptions relating to chromium, whereas those stones relating to precious topaz, these are orange, brownish orange to yellow kind of topaz, and here you see an absence of chromium related absorptions. So we have actually quite a good objective criterion. When we look at it in terms of the ColorCodex system, that objective spectroscopic criterion also plays quite well to the color appearance. And so we find on the 30 series sheet of the ColorCodex, we see this boundary of where we're able to distinguish between what we would classify as precious topaz and what we would classify as imperial topaz. And then as you go on to the next page, which is this 40 series sheet, you see here we're only talking about the topic of precious topaz. If you go in the opposite direction, we see here we're only talking about the topic of imperial topaz. And so we find a very good complement in the ColorCodex system, a visual-based system, with the objective or spectroscopic data that we've collected. An important one for the industry, obviously the copper-bearing tourmalines, Paraíba and Paraíba type tourmaline. This is just kind of a quick diagram to show some of the dominant chromophores you have in tourmaline. On the left, you have manganese. Here you have the pink tourmalines, the rubellites, purple tourmalines. On the right, you have the green tourmalines, which can be colored by iron or the combination of chromium and vanadium. And in this triangle in the middle, you see these are all the range of colors that you have copper bearing, where copper is present. And what may be surprising to some is how broad this range of colors you can have where copper is present. You see a distinct range in the intensity of color, but you also see a very broad range in the actual hues or the colors that you're able to achieve. So we use a similar kind of thing here when we're distinguishing the Paraíba or Paraíba type tourmalines. We use spectroscopy, very effective tool for recognizing the presence of copper, or whether this is due primarily to iron or whether it's due primarily to copper. Even though the color appearance can be quite similar in some of these stones, spectroscopy provides a very definitive basis for us. But within that range of tourmalines that actually possess copper, are there other variables which are going to limit those stones that may get called by the variety of Paraíba or Paraíba type? So is there a certain color intensity? Are there certain hues that are falling outside the range? So these are the kind of things that we're looking at kind of as a future progression. We're looking to work with other organizations to see if we can't harmonize some of these things as well. But where we've done a little bit of work is the iron-bearing tourmalines. So here we have verdite and indicolite. Again, these are two much older traditional kind of terms. There's a fundamental understanding that verdite stood for kind of green tourmalines, indicolite stood for blue tourmalines, but where is this border? Where are these borders encountered? And stones that you find, for example, in the middle of these two, how are they going to be classified? So we've looked into this. So we've already identified these as iron-bearing tourmalines. And here we have the 80 series sheet. And I chose the stone on the left I wanted to highlight because this was a stone that actually came in from a client. And the client was adamant that this stone was indicolite, or should be called indicolite. But we, as a laboratory, we did not classify it as indicolite. Unfortunately, at the time, we didn't have the ColorCodex system where I could demonstrate this easily. But the stone on the right is a stone. On this page, this is really the only column of color where we recognize the indicolite kind of varietal classification. As you move to the left, you see a progressive increase in green coloration. And here you're falling outside now of the indicolite varietal call. And you see the stone that had come in from a client several years ago. This is a stone that actually sat well outside the boundary. And so again, with the ColorCodex system, it would have been very easy to demonstrate this to our client. On the next page, we see we've got a pear shape in the middle, which is about the bluest iron-bearing tourmaline that I've come across. And so we see where the boundary to the indicolite variety is in this sense. As you progress a little bit further to the right, you see an increase of a violetish or purplish color component, which I've not encountered so far in iron-bearing tourmalines. What this also highlights is how restricted, how small actually the indicolite color variety is. It's much rarer than people realize. And so this helps to demonstrate that. It's quite a rare and quite a special color variety for tourmaline. Another one that we utilize is blue tourmalines, or blue spinels, I should say. Spinels you have in the blue family, you have those that we classify as just blue spinel, and you have those that we classify as cobalt spinel. So one of the things that I do to highlight to this is to show that although cobalt is rare in spinel, it's not as rare as we originally had thought. All of these stones that you see across the top, these all have traces of cobalt. We can recognize it in the visible spectrum. But it's only the stone on the furthest right that we actually classify as a cobalt spinel. And that's because the predominant chromophore is cobalt. And so we're able to use, here's an example of some stones. I'll move on to spectra. We're able to set, again, objective criterion here. Here you're able to recognize that although there might be some iron, some Fe2+ and 3+ present, really the dominant chromophore is the cobalt 2+. When we move over to what we classify as a blue spinel, these also have cobalt. But what we see is the presence of the iron, the divalent and the trivalent iron, relative to the cobalt 2+ is much different. And so iron is a much more important influencer of the color here. And so you start to fall out. You could have others such as chromium and vanadium, which can also be in effect. But we start to see how we have set up objective criterion to distinguish those stones that we would classify as a blue spinel or a cobalt spinel. And when we take that criterion, one of the things that we separate those stones, one of the things that you also see is that actually visually they look different also. The stones that we classify as a blue spinel, these look more like a steely blue kind of color, whereas the stones that are predominantly colored by cobalt, they have a more quintessential cobalt blue color, for lack of a better word. And as a result, because we can visually see this, we've also been able to start setting the parameters for this using the ColorCodex system. We're also looking at other varieties. Obvious example is emerald and green beryl, but there are a number of them across our industry that we're looking at. And slowly but surely, we're looking at trying to set up some boundaries as recommendations for the trade. So now I actually just want to come back to this topic of trade terms, because again, we talked really quickly about the development, why we kind of see the introduction of trade terms again in our industry, but are they really kind of accomplishing or satisfying the goal that we need? And this is something that we have to look at, because these are things that are not well structured. And so here are 5 stones. Regardless of how you may see colors on your screen, I'm sure you're going to very quickly recognize that these are 5 different colored stones. And so you can have a very nicely colored ruby, but you also have stones that are dark, almost blackish, overcolored. You have stones that are slightly purplish, you have stones that are pinkish. And these are all stones that have received the pigeon blood comment or description on a laboratory report. So you start to see this is why we don't have kind of a common understanding. And we've unfortunately taken a term like pigeon blood, which was almost revered in our industry to mean the best of the best. And now it's been commercialized to the point where it's really almost meaningless. And this is why I personally, I was sad to see this kind of happen, this evolution or development to take place. I'm coming back to this slide with the Munsell Color Book, because this is to again demonstrate why systems like the Munsell Color Book haven't been able to be helpful in answering these questions. What if we want to use these terms, pigeon blood, royal blue, and so on and so forth? We need to set boundaries. We need to set definitions for them so that it has meaning. And up until now, with the use of, for example, you see with the Munsell color system, this hasn't been possible. And so you may hear some gemologists have expressed on other webinars that there's not ability to create these kind of standards for pigeon blood, universally accepted for pigeon blood, or for even the ruby and pink sapphire borders. But this was because of the limitations of the technology that was used in these other systems. However, when we look at the ColorCodex system, this is actually ideally suited to help answer these because of this expanded gamut of color that we've been able to achieve, and the fact that the way that these are produced, because they present and represent color more the way we see them in stones, it's a much more effective tool at helping us to answer these questions and really address some of these questions for the industry to help bring better clarity, better understanding, and better structure. And here's another slide with a succession of stones that received pigeon blood calls. I don't want to harp on this too much, but all of these received laboratory reports. So now, if somebody was to be offered a stone, you can ask for a ColorCodex reference and actually see what is the pigeon blood color that's being offered to you. And so now you can have a reference to understand and an expectation of what you should receive. So just to kind of quickly summarize here, This was a system, again, I developed this because of a real need that I felt the industry had. It was developed for this industry, specifically for appraisers, for valuers, jewelers, gemologists, gem dealers, laboratories, and so forth. It's an observer, it's a direct observer-based color comparison. This is allowable because it best mimics the way the color is seen in transparent faceted stones. And it's very easy to use, it's very intuitive, but most importantly, it allows for consistent and repeatable results. For anyone who's interested, there's this publication of In Color magazine we published information on the system. We showed the number of the slides that you have here. They're printed there for reference. Or if you want to see, there was a presentation given at the ICA Congress last October on the ColorCodex website. You can also see that presentation for those who are interested. Just a short note on lighting, because obviously lighting impacts the color of a gemstone. It can also impact the way color is perceived with the ColorCodex system. So we've gotten involved in this, and we're looking at developing a light source, which is a good full spectrum light. We're very close. So I hope to be able to update people in the not too distant future on this as well. And this is all, again, just to bring better standards, better clarity to the industry. So that's pretty much it. Thank you very much for attending. And any questions that you may have, I'm really happy to answer.
So there is one question, Mr. Smith, about the ColorCodex. It's from Frank Braden, and he's asking about, are gray and brown dealt with under tone or under saturation?
So it's the tonal value. It's a third dimension or the third factor in color. And so on the sheets, again, this is handled through the use of overlays. You have 5 different levels of tone. And so as you are looking at stones, you merely place the overlay over the respective color windows to better match the stone. And then you include that reference. So you have the color reference of the window. You have the column. For example, I'm just looking at one, say it's a 60, the level of intensity is an 07, and then you add plus G1 as an example for the tonal impact. So those 3 numeric values then represent that particular color.
Yeah, so that means the overlay will represent the gray and brown color, right?
Yes.
Okay.
So sometimes,
yeah, so that's
sometimes when you're using the overlay, it's not that you visually recognize it's a gray color component or it's a brown color component. You just see there's an element of tone which is present. And so it's not always translatable to something where you're going to say, oh, this would be something which you would describe as grayish, or this is something you would describe as brownish. It's just some stones, it's subtle, the tonal impact. So it just shifts the color a little bit to create a better match for the stone. One, the gemstone industry has a universally accepted system. This is false, we don't. The diamond industry does, but the colored stone industry doesn't. So this is a false statement. The ones who went true, they might have been also thinking about the diamonds. I didn't think to specify specifically colored stones. And then the overall appearance of colored stones, it's this combination of brilliancy, color reflections, windowing, blackened areas of extinction. This is true. This is what comes together and converges to create the overall impression that you're looking at a stone. For 3, the ColorCodex system uses a numeric value as opposed to verbal descriptions. This is true. Let me scroll down here a little bit. Gem varieties based on color alone are well defined. Yeah, this is false. You have very generalized verbal descriptions which exist in the trade, but these, you can take something like red. A ruby has to be red. Well, there are many shades of red, so it's not just a verbal description. And this is why I say that. Also, the colors. So the last one, the ColorCodex system is a tool that can help gem dealers communicate. This is true, and so this can be used again, even if you don't have access to the stone itself, just by receiving the numeric value of the ColorCodex reference, you're able to compare it to when you have the ColorCodex system to the stone that you have, and whether it's a good match or whether it satisfies what you're looking for in a particular gemstone.
Okay, so this is 5 points. So let's go back to the questions again. So the second question will be, how does one verbally describe the numbers using the ColorCodex system?
I'm sorry, could you say that again?
Yes, so this attendee is asking, how does one verbally describe the numbers using the ColorCodex system?
Well, that, again, I purposefully didn't want to get kind of stuck on that point, because I didn't want it to be, if I see a color window that has a particular numeric value, I'm looking down at a sheet that has green colors. And so let's say the numeric value is, the ColorCodex reference is a 6007. So from our laboratory position, we may describe that color in a particular way. Maybe we're going to say that's a yellow-green color. But someone else, the way that they interpret color, or perceive or want to verbalize color, they may describe it as a greenish yellow, or they may describe it as a yellowish green. Another laboratory may find they prefer to describe it in a different way. I didn't want to get caught up in trying to tell people or dictate to people how they have to describe a color. What I was producing was a tool that allowed them to reference the color.
Yeah, exactly. Yeah, that's true. So next question is, will the lockdown and the rise of digital technologies in gemstone dealings increase the application of ColorCodex in the color gems trade?
I think it will, yes. Again, I think this is a tool, as I explained, for the benefits of the system and the increase in the color gamut and the way that it's presenting color more like you see it in a colored stone. I think that we will see it. We've already seen this. We've had a number of laboratories who have acquired the system. We have a number of people in the trade who have acquired the system, a number of important retailer groups that have acquired the system. And I think they just see the benefit that this system allows when they're trying to discuss whether it's the retail branches between different branches around the country or around the world, but also, again, to communicate with their suppliers what they're looking for, what their needs are, and so forth. So I think that it's a tool that will lend itself kind of well to some of the changes we may see happening post-COVID.
Yeah, thanks for this answering. And the next one will be, will the size or the shape of gems impact color?
That's a tricky one. It's a geometry question, right? So
yeah, exactly.
The shape and cutting style can kind of impact the color impression. So if you're doing a color reference for an emerald cut stone, you're going to want to be matching it with another emerald cut stone. If you try to compare an emerald cut with an oval modified brilliant cut, you might get a little bit of a different color reference, but you have a different geometry in that respect. One of the things that you need to handle, though, is windowing is an issue that you need to kind of contend with. And so in the booklet, we kind of suggest how to handle the topic of income, when you don't have a full brilliancy, so you have windowing, how you want to address that when making ColorCodex references.
Yeah, exactly. Yeah, this one focuses more on brilliance and not about the shape. So what about the next one? So to what extent does a stone's fluorescent reaction impact the color description or also its color stability?
So this is why we need to have a standardized light source, because the different color temperatures different temperatures of the bulbs are going to impact the color of many gems. And so this is something why we need to develop kind of a good full spectrum bulb. We actually don't have one presently in the industry, but I think we're close to being able to offer one up for the industry.
Okay, yeah. So I think the next one also is similar about that one. So it's from Miro. So he's asking, firstly, he thanks you very much for the excellent presentation. So he's asked how ColorCodex can handle gemstone with fluorescence color. And taking an example, what will be the plate code for Burmese pigeon blood and the so-called Mozambique pigeon blood? Are they different by the tone only?
So these are, we're getting trade terms. So these are realities. You have this, these pigeon blood calls being applied to a wide range of stones. Just if I can use an example that we had from the ICA Congress last year, and it kind of shows the kind of how easy the system is to use. I had some dealers, some traders come that had not seen the ColorCodex before, but they were looking at this. They wanted to say, you know, how are we going to be able to communicate the difference of this ruby, which is a very nice color, to the difference of that, of another ruby from a very nice color. And so independently, he and I, we looked at the ColorCodex, and I told him this is the ColorCodex system is perfectly suited to handle this. So we looked at it, and he made a color reference for his two stones, and he found that you had two different color references for the two stones. Both very nice colors, but two different color references. And when I made the color references, we actually made the exact same color reference. And so I've been working with the ColorCodex system for a long time. It's kind of understandable that I would be able to quickly come up with a color reference. But he had looked at it just for a few minutes, just a couple of minutes, and he was able to make a color reference. And the same color reference that I was making. Now, obviously, he's a knowledgeable person in the trade. He has a lot of experience, so he's used to looking at color. He's used to recognizing nuances and differences in color. So the ColorCodex system really helped him demonstrate that if he wanted to speak with one of his retail clients in another location. So you do find that what gets called pigeon blood of a Mozambique origin. You have those with higher iron and those with lower iron. They also tend to have different ColorCodex references, or you have stones like Burma, which have a lower iron, but maybe higher vanadium content. They also get a different ColorCodex reference. And so the system is able to highlight these differences and demonstrate these differences.
Yeah. Okay, so one question is about how can we use the ColorCodex to bicolor stone?
Okay, yeah, bicolor stones again in our pamphlet in the beginning we kind of addressed this because the only way to really do a bicolor stone is you make two separate references. So you make a color reference for one area of color and you make a separate color reference for the other area of color. And so it's the most straightforward way to do it.
Yeah, that's true. Maybe use two color reference system. So now it's one more about the question. Can this system replace a collection of master color stones?
I think yes, it can. You know, once just as an example, I showed where for AGL we've set the boundaries for the Padparacha color variety. So you have those stones on the pink border and you have those stones on the orange border. And up until now, or prior to the ColorCodex, I had a whole line of stones that I had collected that were showing different ranges of intensities. But as it stands today, what we use the ColorCodex system. So it's much more repeatable, it's much more consistent. And again, for those who have it, they're able to then use the same standards. You know, just as a kind of side story, one of the people from the trade that acquired the ColorCodex system, he called me about a stone that he was being offered. He had to make a decision on whether to buy it or not. And he wanted to know whether this would be a Padparacha in the AGL classification. And so he said, I have your ColorCodex, and he gave me the color reference. And so using this color reference, I went to our ColorCodex and I was able to see this falls within the range of what we would classify as Padparacha. And so he was able to buy with confidence the stone, and he submitted it and he got the Padparacha call. So it helped him facilitate his decision on whether to buy.
Yeah, thanks for the answer. So there are two questions I think are similar. So it's about how useful will this be with less translucence, or is this system only for the transparent stones?
So this is a system really that's best suited for transparent stones. In all honesty, the world of color, which is printed on paper, this is fine for translucent stones. this system is actually quite good and quite adequate for such stones. Where you have the challenges in the other systems is when it's transparent, faceted gemstone. And that's what this system is specifically designed to handle. So you have other tools to help you with translucent stones.
Okay. So can the atomic table be color coded? The atomic table can be color coded. I don't understand this question too much. So can the atomic table be color coded?
I'm not quite sure what they mean by that. The color of a gemstone is related to its chemistry. So I don't know if the question relates to that correlation. But you can also have different chromophores which can achieve the same color impression. We had this example of the tourmalines. So you can have some iron-bearing tourmalines that really have a very similar color to some Mozambique Paraíba type tourmalines, as an example. And the Mozambique Paraíba type tourmalines is due to copper, whereas the other ones, for example, from Afghanistan or other locations, is due to iron. So it's not trying to help you define what the chromophore is, it's a color matching system.
Exactly. So,
I hope that answers the question. I'm not quite sure I understood it fully, but.
Yeah, I think she commented iron in tourmaline and copper very different in tourmaline.
Yes, they are different chromophores, absolutely. But when it comes to creating color or the observed color in a tourmaline, they can produce very similar colors with the examples that I just gave. And so two different color causing mechanisms can produce actually remarkably similar color appearances.
Yeah, that's true. So it seems many people are very interested to buy the ColorCodex, and they're asking about the price of the ColorCodex.
Okay, so the system, you can go to the website, color-codex.com, and there you can purchase the system. The system costs $2,000. So it's not an inexpensive system. This is there's been a lot of development and engineering that's gone into this. They're also all handmade. So it's an expensive process to produce. As a result, there's a cost to the system as well.
Yeah. So don't worry, tomorrow we will have a follow-up email, and I will put the website address there so you can purchase the ColorCodex there easily. And by the way, maybe the last question is about, do you have some other books so you can recommend about the color?
Sorry, as far as the ones that are available to the industry, I think I showed them before. The World of Color has it's been around for several years. You have Gem Dialogue. This has been around for many years.
Mm-hmm.
So I think for those people who are used to working with them, if it works for them, I'm happy. I have no problem with that. Same with Munsell. For those people who feel the Munsell system works for them, I don't have an issue with that. I'm not saying that you can't or shouldn't use another system. I've just developed this because I feel it's a better system. But if you have one that you're comfortable with and works for you, I say use it.
Yeah, it depends on everyone. So you can just choose whatever you want, you prefer. So that's just Mr. Smith mentioned in the maybe the first presentation about the color referencing system is about like maybe Gem Dialogue, the World of Color, yeah, and Pendant, Munsell, you can also recommend, yes. So I think yeah, he didn't hear the cost. So the cost will be $2,000 US, yeah, $2,000 US, yeah.
And so again, when you think about the cost, when I've had some people ask, some people in the trade, because obviously cost is always something they want to discuss. I've asked them, so how many times have you had a stone which you have sent to a client? So you've paid to have the stone sent to the client. They look at it, but it's not satisfying what they need, so you have to pay to send it back. So you have insurance, you have shipping costs and everything else. How many times have you done that, and what's the cost of that? And so this system can help you mitigate those costs. So you're actually saving money from sending stones unnecessarily, just as an example. So it's also a tool that helps you to save money, that can help you save money.
Yeah, okay, so thanks for answering this. And I think this will be the last question. Is about this, they are concerned about the ColorCodex book is heavy or portable? It's a book, actually. I think it's portable for me, actually, I feel.
So this is the book here. So it's, I don't know how much actually it weighs, but it's not very heavy. It's not very heavy.
Yeah, exactly. So I think that's all the questions. Yeah. So thank you so much, Mr. Smith, for your patience for answering these questions.
It's my pleasure.
So
my pleasure. Again, thank you for inviting me.
Yeah, our pleasure. So we are finally so happy to have the chance to get you here to explain to us about the ColorCodex. I think it's a very useful tool for maybe most of the laboratories and the institutes. So thanks again for inventing this effective color referencing system.
Thank you. My pleasure. My pleasure.
Yeah. Okay, so thanks again for everyone for attending this webinar. So please pay attention to our next webinar. So I will see you next time. So thanks again. So thanks. See you next time. Bye-bye. So bye-bye, Mr. Smith.
Thank you. Bye-bye.
Thank you. Bye-bye. Bye-bye.